Welcome viewers to EPG Pathshala for Architecture M-Mark students. Let us continue with the vector analysis, a method of analyzing the data using vector data. In GIS, as we have seen, vector data and raster data plays an important role. You can store the data in vector format or in raster format. So, storing the data and then analyzing the data forms two important parts: simple scanning, digitizing, making the system to understand, and then saving it as a vector data or raster data is one part, other one is analysis. Vector data analysis, as I was just telling you about overlay analysis. As you can see here, this particular image or layer consists of two polygons. To make it simple, this is the second layer which has got another two polygons. This is the third layer which has got another two polygons, each at different directions. When I overlay them, when I just combine them, you will see that n number of polygons are formed by this intersection. So, all these layers, all these objects which are present are reproduced with small bits of polygons. This could be A plus B, this could be B plus C, or something like that. Combination of what is present in these three layers are shown here. This is what is the major advantage of your vector analysis. It just combines the data. Invariably, most of the time we use only vector, your intersection in GIS. Sometimes you may require your application like NOT, XOR and also OR. Otherwise, it will be only intersection. So, we are talking about, say, point in polygon overlay. You would like to know which are all the metro stations which are located in the forest areas. So, that is your requirement. So, this is the layer which is consisting of your metro stations, and this is the layer which is actually your forest area and forest map showing the forested area and the non-forest area. So, when you want to know that the condition is that metro station located in forest areas. So, you do not have to worry about all these things because they are all in the non-forest area, but here they are all in your forest area. So, by choosing so, there are 1 and 2, two of them are there. You can see here how it is there. So, the system will select these two points which are present here. It does not give, I told you last time itself, we will just make a selection because it is more of a visual analysis, but still selection will be there. If you want, you can store it as a third layer also. Now, here these are the two polygons. It says a table says polygon consists of 2 points here, 1 and 2 in your forest area and 3 is in a non-forest area. Simple analogy, simple system. So, whatever is required is added. You should remember the attributes of your polygon. This is a metro station, this is say your forest map. So, this will contain different type of details or attributes, and this will contain different attributes. Advantage is that they are put together. So, the ID of that particular point and its land use or the usage as far as is indicated and clubbed together. So, both the attributes are joined and then a new table is generated for this particular layer. So, that is an advantage. Point in polygon, what exactly you are going to do that? This is another method of doing it. Say something like join the data, spatial join we call it as. That is, the attributes from one feature class is joined together or added to another feature class. Based on what relationship? The spatial relationship that those two objects share with. A very interesting one. Whenever we make or we try to make higher officials to understand the importance of GIS, they say, sir, we already have details pertaining to this particular village and town. Everything is there, sir, everything is there, sir, in the form of your Excel sheet or any other spreadsheet. So, when I have that one, what am I supposed to do? How am I going to analyze that? How am I going to understand that? So is it possible once you create a GIS map, is it possible to link that? Yes, it is possible. A pointer or a common field is being used. You spatially join the data. What is that you are supposed to do? You just ask the system to select those records from the Excel which are matching with the condition what I have prescribed in the map, and that will be updated into a new layer. So a very important one, because you may have many times 200, 250 columns of data. Records can be more, but the columns are important. I can't be retyping the entire thing because already we have spent a lot of time and resources, money on your typing the data. Now I have to link that to some other method, some other object. So spatial join, transferring the attribute from one feature class to another feature class. Calculating the geometric intersection for any number of feature classes and feature layers. I told you about intersect. How does it do? Geometrically it calculates. In fact, you must have seen the earlier, this is the one where you have seen this, see how it gets intersected. And a new layer is formed with n number of polygons when compared to the first. So 1, 2, 3, it's just a combination, depending upon the intersection it will be forming. So that advantage you will have in the case of intersection. So that part of the feature which are common to the both inputs will only be selected and shown in the output feature class, depending upon what condition you are given. Line in polygon overlay. A road network which is cutting across some forest, because environment is such an important thing nowadays. People talk about how well you can use GIS. So let us see that. So for example, I am talking about this particular road. It is passing through forest area. You would like to know which part of the road is passing through the forest area. You can select that part alone by intersecting this. So what will happen? This line passing through this one, this part. So you can say that separation here, and this is the line. So part of it, 1, 2 is split into two parts, namely 1 is split into 1 and 2, 2 is split into 3 and 4, and 3 is renumbered as 5. So 1 and 3 are those lines which are in forest area, whereas 2, 4 which is outside is not. Of course, this 3 is 5 which is already outside the area. So you, depending upon your application, so all your knowledge, interest and the importance of kind of application. So that based on that one can get the output. So the roads passing through a forest area can be detected. This is not the only one method, any other method can, and the other thing also can be done. Then polygon on polygon. What kind of analysis one can do? So we would like to find out, there is a resort. So which are all the areas covered by forest or within the resort boundary? This is my resort boundary, maybe 100 meters buffer or actual boundary, and I want to find out which part of the resort is covered by forest area. Because there are two things. One, you can talk about environmental aspect. Other one, you can even discuss about your using this forest area as an attraction to the tourist. So the data set will contain the combined polygons and attributes of both data sets. That's the best part of it. So this is how you use the, because we will see in detail how effectively you can utilize this one. So you would like to know identify or identity operation. An operation which forest areas fall within the resort boundary. So naturally what will happen, this is the one. In the previous case, it was just overlaying that and then find out covered by forest area, which areas of that. Now you see here exclusive, something like clipping that. So this much of forest area is falling within your, say, your resort. So this sort of analysis was say identity operation. Of course, intersect operation. You would just try to split that. So this is an independent layer, forest map, this is a resort layer, and you want to intersect, and you just give an and. So this will contain those forest areas within the resort. So previously you had both resort area and forest area. This will give an exclusive forest area. This will get calculated, and you can see, of course, again and again, time and again, I am telling you, it all depends on what kind of analysis you are making. So you can try to get the details according to your requirement. But remember that in each of the cases, the output is very important. So here, this particular output will contain features and retains the original input attributes as well as the attributes of the input feature, that is your intersected feature, namely you are say forest area. So this is how intersection goes on. Connectivity operations. So this will try to link multiple entities in the same database. What kind of analysis you can do? When linkage can be done when you have something like A is a direct neighbor of B, or they can be connected via sub entities. How far is A from B? What is the relationship between A and B? Can all be understood and analyzed. Because depending upon again the kind of application, something like say something pertaining to say elections. You would like to know how far a person has to walk to his election booth. In a city, it is not an issue because all of you find it so easy. Majority of the booths are within a short distance of say half a kilometer maximum. But in rural areas, especially in hilly terrains, it's a huge task. You will have to link in such a way that will give an idea exactly what distance one has to cover, or is it required for me to go for one more booth, though the number of electorals there is much less, because you can't help it. You will have to give an opportunity to everybody to vote. You can't expect an individual to walk 10 to 15 kilometers or 5 to 6 kilometers trekking to cast his vote, isn't it? So in such a cases, you can always think to find out the connectivity between one point and another point, and then try to use your knowledge and intelligence with respect to that particular application, and then come out with a solution. Analysis which I want to tell you how you can use that. Please ignore the names of the various layers. It is all different layers of a particular application. This is a small district area. Various layers are created here. One is geology, geomorphology, soil. All three are your natural resources. Don't brood into what kind of analogy is that. Here you find the various classes of geology, various classes of geomorphology, and various classes of soils. You would like to integrate them. You would like to give conditions and find out how far what is useful for what. I have just taken a simple example pertaining to say land suitability and land capability. Let us see that. Or this is a simple intersection, not land suitability. You can also see work on vector analysis. This case is a simple integration. So we have apart from those layers, we have also land use map. So when I am trying to integrate this sort of n number of layers pertaining to this area with this particular map, it is very important that they all should have the same boundary. Please don't try to ignore that particular point. So when you have apart from this, you can also have the other details like rainfall, post monsoon, pre monsoon, just like that. Any number of layers can be integrated. So in a given area, what is the rainfall in this area, and what is the land use, what is the geology, what is the geomorphology, what is the soil? 6 layers are there. We talk about various layers. In this context, we are just saying geology, geomorphology, soil, slope, or whatever could be there. So in the context of your planning of a city or a town, what we will be interested in is that the road layers, a layer which will be road network, which could be your rail if you have a larger town in that context. You talk about your sewage line as one of the utility. You can say about something water supply or water distribution. You can also say something with respect to a stormwater drain. Apart from that, infrastructure facilities which are present in the given area. This could be some of the layers which we are going to work with a smart city. Here, let me say something like various utilities which are present, something like telephone poles or electrical poles can all be brought out into this particular layer. So when I just try to incorporate all of them, it may appear like a polygon. You can also have a point line, you can also have a line. I have been telling you a point layer, line layer could also be there, a telephone layer, or various telephone towers will be there. You will have TV towers, or it will also be something pertaining to your cell phone towers, all ATMs which are present, and it's important. So when I'm just trying to work with the layers, it's not that I'm restricting myself to your natural resources. This is for example, whereas you can also talk about layers, various layers which are present in that. Again, what is important here is this is the criteria table. I have to decide what exactly I'm going to do with respect to my analysis and my analogy. When you talk about something like say your water supply, what is important here? Where is the point of origin of water source? So you have to take that as one of the criteria. The origin or the point source of water and the distribution. When I am trying to distribute the water, the major problem I will be facing is your slope analysis. So when I want to know that what could be the way in which I can take the water from point A to point B, I will have to understand that. Make sure that that water reaches the end point. This is where most of the time many people will be complaining, sir, we have not received water, sir, they are all receiving water. Similarly, upstream direction, downstream direction. Even in the case of your sewage, when there is a block in a particular region, the first affected area will be the upstream from the point of block, but the downstream will be always not there because there will not be any water moving there. So only the upstream direction of that particular area, this one will be affected. So what we intend to is that, what we wish to say is that, if depending upon that particular criteria what you are going to decide, and the layer will decide what kind of your weightage or the rank you have to give. So you talk about stormwater drainage. Stormwater drainage again is dependent on important factor is the terrain of that region. So when I have undulating terrain, when the terrain is topographically not suitable for constructing a straight line stormwater drainage, you will have to go for a curved line. Then you will have to take the water from one point to another point, dump it elsewhere, and then take it to the river or any other water body where it is going to be dumped. So this sort of analysis. So what is important here is that it's not the layer what you consider, it is the criteria what is important. So as I just told you, depending upon the application, depending upon the importance, you can give the rankings and you can also give the weightages. So that will decide how far you will be in a position to understand your output. So once I get a proper output, then it becomes much easier for me to get into a decision maker. That's what they say. In the case of a GIS, it's more of a tool for a decision maker. Always one can use this very effectively depending upon the kind of application. I can also have many more layers like water quality also. So just a simplicity to make you understand the concept. Please just understand the concept rather than the inputs. Water quality parameters, two parameters I have taken. Okay. So nitrate and the pH. The criteria table. The most important thing are the aspect which will be the, say, your input into the GIS. Criteria table consists of two things. One is ranking, other one is weightages. What exactly you mean by ranking? What exactly you mean by weightage? Just try to understand what I am trying to say now. Don't worry about the contents of it. Ranking is given to various classes within a theme. That means this particular theme, geomorphology, has got this number of classes. Each one of them may be one line or two lines. You can see that various classes. And knowledge about that particular discipline will help you to decide which of them falls in which rank. So I rank them saying that 1, 2, 3, 4. Saying that 4 is the highest or the best rather. It's all debatable, just to give an idea. And 1 is the least. 1, 2, 3, 4. Then next layer, geology. For that particular application, this is the best, this is the worst. Please carefully listen. This is the best, this is the worst. Soils, best, worst, best, worst, and so on and so forth. You try to divide for every layer, you give 4 class ranks, each one depending upon the application. This is within a class. When I want to analyze the same data and I want to put them together, I want to know the importance, the contribution of each of the layer to the final goal, that is weightage. This is given amongst the layers. This is given within a layer, this is given amongst the layers. That means we presume that this particular layer, irrespective of the name, contributes about 25%, 15%, 10%, 5%, 10, 1%, 2%, whatever is that. Depending upon the various weightages or the importance or the contribution level of this, I just give the weightage. So, please understand very well, ranking is within a layer, weightage is amongst the layer. Once you intersect this one, you will have the layer, you can see that layer, each of them will have a rank and the weightage, and then you multiply them accordingly. So, once you just take that, for example, the weightage is 25 and this is your 4, so 100. 25 into 3, 75, 25 into 2, 25 into 1. So, the rank and the weightage is combined together and a new value is formed for each and every polygon for the intersected one. That is, when I intersect them, when I put one over the other, I will have the advantage of. So, what is that advantage you have? Layer 1, layer 2, layer 3, layer 4, layer 5, layer 6. Each of them has got some ranking and the importance. So, I multiply the rank and the weightage, and each polygon will have a new value. Instead of 1, 2, 3, 4, it will have a value of 125 depending upon the weightage, 125, 50 and then 75. So, what will happen when I just put them together and join them together, all of them will get intersected or combined together. You will have a n number of values, all the depending upon the number of layers, you will have that many values in that particular polygon, the final output. So, you try to understand and work on that. So, what exactly we do? It is all scientific. What I told you till now is about some concept. Now, it is the scientific way of understanding that. Now, I have merged all the n number of layers. Layer 1, 2, 3, 4, 5, 6, 7, 8 have been merged, and a final layer is obtained, and that final layer will contain a polygon which will contain all the inputs from all the different layers. We will have to add them, and obviously the minimum value will be 100, maximum value will be 400, because if I have 1 in all the 8 layers, then 1 into its weightage, total will be 100. If I have 4, the rank into that weightage, it will become 400. So, you go and simply try to understand the statistical parameters. Once I get the statistical details, I go for the mean and the median, and I distribute the values in such. So, now again it is all scientific, there is no specific application, it is all simple mathematical and statistical analysis. So, what I do is that I take the mean and the standard deviation. I know the total value, I know the minimum value, I know the maximum value, I know the mean, I know the standard deviation. That is the 4 parameters from statistics I get. So, what I tend to do is that now classify the data according, let's select these polygons accordingly. How? So, what are the values based on, I told you 100 to 400. So, what I say is that highly favorable zones in my context is that mean plus 2 sigma. Moderately favorable zones, mean plus 1 sigma. Poor favorable zones, 1 minus 1 sigma. Least favorable or low favorable zones, mean minus 2 sigma. So, it is very simple and straight. Now, the values are mathematically calculated. So, we are not bothered or worried about whether it is correct or incorrect, a method of approaching getting the values. So, now you will get an integrated output like this, each of them showing highly favorable, moderately favorable, poor favorable and least favorable. Apart from that, you also have some of the other features like your water bodies, which are all not included in your analysis, that you have to bear in mind, because they do not have any significance, they do not provide any kind of input. So, we just, of course, we can also give that depending upon the application, but in this context we ignore these objects and then we combine them, and this is how the data is integrated. You see how well the data has been obtained. Highly favorable, moderately favorable. So, this green is your highly favorable, whatever may be the application, do not worry about that. This is highly favorable for that particular application. This is next moderately favorable, less favorable, and least favorable is your. And incidentally, in this context, you find it is very close to this particular river. This is the least favorable. Whatever is the application, again I am telling you, depending upon that. So what one should remember is that whatever you have in the context of your study here, this analysis is important. How are you going to split the data? If you are not going to split the data properly with the purpose, you will end up with a output which is wrong. So the integration is one part, I don't deny that. You have to integrate the data, you have to finalize the data. So these are the various inputs what I have given. 8 of them are input here, and I generate a criteria table. That criteria table has got a ranking and the weightage, and the ranking and the weightage will decide what exactly I am going to do with the data. Don't bother about the values. So ranking is within the layer, weightage is amongst the layer. Now what I try to do is that I just integrate them together, intersection, and every part of that 8 layers will become one single layer, and each polygon will have 8 different values. So that's the most important thing. That is 8 different values means from each of the layer, the ranks and the weightages, and you will be in a position to understand how exactly I can split them. So for splitting, you are going again for some scientific method, go for statistical details. Once you get the statistical details, you get your count. What is that count? 721 is there. You have the minimum and you have the maximum, and you also have the value which is some data are not an issue for us, and then the mean and the standard deviation. So these values are put together, and then based on that, I was telling you here how you calculate the mean plus 2 sigma. So that means we just take the mean value plus twice the value of your sigma, the standard deviation. So this value plus twice this value plus once this value minus twice, this value minus once. So this is how you analyze the data and then come to a conclusion how these effectively. So vector data analysis is not only applicable in natural resources, also applicable in various applications. Something like, say, we are trying to work on say smart city. You are interested in understanding what is present where, and you get maps, various maps. And you must have seen in many cases when somebody is developing a huge land for say residential areas, they try to say that you have a school there, you have a gymnasium there, you have this, you have that and everything. Because it may or may not be true, that is not our concern. I am just trying to say that when you have such a detail, what we do that we just try to understand, okay, if I just go and stay there, I have these other facilities. Now apart from that, that is within the campus. Now apart from that, I would like to know where is my nearest hospital. I may have a small clinic in my community center, but not enough. Where is the hospital? How far is the hospital? So you decide the criteria, you design the criteria as an architecture, as an engineer. You just try to think, okay, these are the things, or these are the parameters which I have to decide. Okay, we talk about say something like water flow. Everything in that particular community may be collected on one particular place. Where am I going to dump the water? That's for sewage dumping. Am I going to collect to the main or distribution when I go get the water supply? So one is supply, other one is collection. So this sort of a planning you require GIS. GIS is the best tool in which you can effectively use that. And then, so you also have stormwater drainage, draining of your rainwater. Whatever happens, you cannot allow the water to stagnate for a long time. You cannot be elevating your area with respect to the surrounding to infinite levels. You'll have some control. You'll have some constraints. Even authorities will not allow you to raise your house beyond a particular height, saying that it's my house, I can't do anything. You can't do that. So what they tend to do is that they just plan according to the requirement is there, the plan is there. That is one part. This is a community. When you talk about a smart city, when you talk about Amrit city, I was telling you these are the things which are likely to come in the future. So what is that I am going to do? As an architecture, planning is an important thing. Definitely, you can use your technology for small areas of 100 hectares, 200 hectares. When you talk about a city level, 10 square kilometers, 20 square kilometers, 30 square kilometers, then it's not possible for you to use your simple CAD technology. You will have to use only GIS. So that's what I just feel, that vector analysis will form an important role in analyzing this. Thank you.